So today's lesson is going to be on adding and subtracting with our fractions. So just to kind of reset our foundation for the concept of add subtract, I have a couple of really basic examples of adding and subtracting fractions at the top, and then we're going to jump into the stuff that you're going to see more of in this unit. So the first one, we have 5/6 plus 7/8. All right, what's the main idea that kind of goes along with adding or subtracting fractions? What needs to be true?
You have to have the same denominator.
You have to have the same denominator. The common denominator is what we refer to that as. So if I have 6 and 8, I need to figure out what the common denominator would be between those two. So a common denominator between two numbers has to be the least common multiple.
4.
Do you know what I mean by that?
8.
Not divide by.
Multiply.
They have to multiply up. You can't go down, you have to multiply up. So it's the least common multiple that they both multiply up to. So you have to think about the multiples of 8, and the multiples of 6, and then the one that they both have in common that they can both multiply up to. So what is something that 8 can multiply up to that 6 can also multiply up to? 24. So 24 is going to be our least common multiple. That's going to be our common denominator. Once you identify what the common denominator is, you're going to multiply the top and the bottom by whatever you need to get there. So how would I multiply 6 to get 24?
4.
Times 4. So that would be 20 over 24, right? So do top and bottom. What would I have to multiply 8 by to get 24? 3. So that would be 21 over 24. And once you have this, how do you actually do the addition? Add the tops. 41. Do you also add the bottom? No. The whole point of getting that common denominator is so that it stays common denominator. Remember that idea of like terms. Doesn't matter what context you're in, if you guys are adding or subtracting, it works like terms. That thing that makes it a like term in this case, which is in this case, the denominator of 24, that needs to stay the same. That's the like term. Okay, so 41 over 24. Say again? Simplify? I mean, if you're just working with numbers, you would. This can't simplify. But if you were working with numbers, you would. But you're going to see that what we have, that's not really going to happen. All right. Oh, also for this one, you guys see how 20 over 24 can be simplified? Would you, after multiplying times 4, would you then simplify it before you add them? That would undo everything you just did, right? Keep that in mind. It's an important thing to remember. All right, then once we switch, so it's not just numbers, we have variables now. So you're going to think the same way. We're just going to kind of split it up. So we're working with the numbers and then the variables. So if I'm just looking at the 6 and the 9, 18 would be the common multiple between those two. So that's the 18 part. Then I look at the x and the x squared. What's the common thing that they can both multiply up to? X squared. Because x squared can multiply times the 1 and just stay x squared. Or you can multiply x times x to get x squared. Right? So whenever you guys are working with variables, like monomial expressions like that, the least common multiple is just whatever the bigger one of them would be. So if you're comparing x to x squared, the least common multiple is the bigger of the two, x squared. So my common denominator needs to be 18x squared, so I'm going to multiply each fraction by whatever I'm missing to get there. So what would I have to multiply times 6x to get 18x squared?
3x.
3x. So I'm going to multiply both top and bottom by 3x. Gives me this. What would I have to multiply the second one by to get 18x squared? Just the 2. So starting at the x squared has the 9. I just have to multiply times 2. So it's going to be 8. Okay, so I transform my fractions so they both have the same denominator. And I'm going to link the numbers in the top. Now are 3x and 8 like terms? So how would you write that?
3x plus 8. Oh, minus. Yeah.
And that would be your final result. Okay? So all in all, when adding or subtracting rational expressions, you must have common denominators. That's our key concept here. Denominators. Common denominators. Now, you'll understand that, you'll know that, you guys already knew that before we came to this lesson. The trick for this lesson is actually getting that common denominator. Okay? So now with some more difficult examples that we have here, finding the least common denominator, or common denominator, no, the least common denominator. So this is the process you guys are going to follow. First of all, you're going to factor just the denominators. Because again, remember our focus for adding and subtracting is the denominator part, not necessarily the numerator part until we're actually ready to add or subtract. So your focus at the beginning should just be the denominator. So you're going to factor the denominators. You're going to write one representative of each factor that is present in all of the denominators across the entire question. So you want to write one representative of every factor that exists, because you want each factor to be represented in your common denominator. Any repeated factors, so if you see a factor more than once, just write it once. Okay? And then anything, obviously, that you only see once, you'd represent that once as well. So we're just writing one representative of every single factor that we see within the question. And then if you guys are working with monomials, you're going to treat them like up here, like we did up here. Okay? So this is how you find the common denominator. You factor everything, and then you write one representative of every factor that you see. That will be the common denominator, is one representative of every factor that exists. And then once you know what the common denominator is, obviously you have to multiply each fraction by whatever you're missing in the denominator to get it to be that common denominator. And that's kind of where the work is for the question. So let's just jump in. So here, what I'm going to do is I'm going to go ahead and factor each of these. Let me see how I organize the working here to make it as neat as possible. Okay. So this little box right here, all we're going to do is practice with the denominator. We're not actually going to do the addition or subtraction. All we're going to do with this entire first page is just practice finding denominators, common denominators. Okay? So, how would I factor just this part right here? Whoops, what in the world? That was not right. Again, when you guys are trying to find the common denominator, leave the numerator. I'm not going to touch the numerator at all. I'm just going to leave it alone. But the denominator I'm going to factor out at 2 using a GCF. So that's the first one. Okay, again, for the second one, leave the numerator alone for a second, and then I'm going to factor the denominator. I can use a shortcut for this one, remember? So I have two factors. What two numbers multiply to get -6 but add to get -1?
-3 and 2.
It should be -3 and +2.
Would you do the whole crossing?
No. Addition or subtraction does not cancel ever. There's no canceling. No canceling in addition or subtraction. Especially not in this section, or this part of the question. Alright, so once you guys have factored everything, all I'm doing on this page, we're not going to do the entire question. We're not going to get all the way to the answer. All I want to know is what the common denominator would be. That's what we're practicing here, okay? So all you guys need to do to find the common denominator is write one representative of every factor that you see. So what's one factor that I have over here? 2. So 2 has to be part of the common denominator. I also see x plus 2. Do I see another x plus 2? But you only have to write one representative. What's another factor? Once you have one of every factor written down, that is the common denominator. So this is what you would, before you actually can add or subtract them, this is what you would want the denominator to look like. So we're not going to do it. This is where we're going to stop for the question. We're not actually going to do this. But if I were to continue with the problem, what you would do is look at each of the fractions that you have right now, and you identify what are they missing. So like in this denominator, what am I missing? X minus 3. So what would I do? Multiply top and bottom by x minus 3. And then what is this one missing? The 2. So I'd multiply top and bottom by 2. So it's the same process as what we were doing here. We identified what the common denominator was, and then we multiplied top and bottom by what was missing to get that common denominator. So that's what we'll see on the next page when we actually do a couple of examples. But for now, we're just practicing finding the common denominator. All right, next one. How would I factor the denominator? X plus 1, x minus 1. Leave the numerator alone. And then how would I factor the second one? GCF of... Alright, so once you've factored everything, now we're going to write one representative of every factor that we see. So what is one factor that I see?
X plus 1.
Okay. So x plus 1 shows up twice, only write it once. And I have the x minus 1, and then I have the x. So this is what the common denominator would be. Usually you write 2 steps in front. Alright, next one. Can I factor x plus 3? No, so sometimes the denominators can't be factored, so you just leave it. How would I factor the x squared minus 9?
X plus 3 makes me
Okay, so again, leave the numerators alone for this process. Just chop up or factor the denominators. Then what's one factor that we see?
X plus 3.
What's another one?
X minus 3.
So our common denominator would have to be x plus 3, x minus 3, both of them together. Alright, what about this one? How would I factor that denominator? I can use the shortcut. It would be 3 and 1, so x plus 3, x plus 1. What about the second one? Can't be factored, so just x plus 3. And then the last one, obviously you can't factor 5. Alright, so then what's one factor? 5, x plus 3, and then x plus 1. Make sense? Okay. So that's when you guys have factoring. Let's do a bunch where it's just monomials. So these examples are going to be just like what we did top right in the very upper box there. So again, looking over here, I have 15x by the x squared. So again, what I want you to do is think of the numbers first and then the variable second. So if I'm just thinking of 15 and 5, what's the least common multiple? 15. And then I have x, nothing, and then x squared. X squared. Like I was saying, whenever you guys have monomials like this and you have the numeric part and the variable part, whatever the biggest variable thing is, the variable with the highest degree, that is going to be the least common multiple. So whatever the biggest one is, that's automatically going to be part of your GC. Sorry. LCD, least common denominator. Alright, over here, 2, 6, and 3. So the least common multiple is 6 for all those. They can all multiply up to 6. And then x, and x cubed. X cubed. Alright, 3 and 4. That would be 12. And then we actually have two different variables. We have the x and the y. So comparing x squared to x squared, and then just y. Because again, you have to have every factor represented, so that variable y also has to be represented. Alright, so is everybody okay, kind of on track with how we find that common denominator? Alright, so let's actually do some examples here. So again, when I am actually asking you to perform the addition or subtraction, here's your process. You're going to find the least common denominator, just like what we did up there. Those examples right there. You're going to multiply both expressions, top and bottom, by their missing piece, so that each of the fractions have the common denominator that you've identified. Then you guys are going to combine like terms in the numerator and put that over the common denominator. So once you have the common denominator set up, then your focus is now going to be on the numerator. Again, you're going to combine everything that you can. And then only after you have one fraction, after you combine the two with addition or subtraction, only after that should you try to simplify. Oftentimes you won't be able to do anything after you add or subtract, but if you can simplify, you would. Never, ever cancel anything during the actual addition or subtraction process. So while the fractions are separated, never cancel anything. Once they're one fraction, then it's okay. While they're still separated, you cannot. Because you'll see, like, what we're trying to do is we're trying to blow up the fractions. We're trying to make them bigger or more complicated. That's the only way we can add them together. If you make them bigger, more complicated, and then trim them down again, you're just going to be back where you started. You'll be going in circles forever. So don't ever cancel during the process. Okay? Alright, let's start with a simple one. We have this guy right here. First thing you want to do is find out what the LCD is, the common denominator. So this one doesn't require any factoring. This is going to be similar to what we just did up here. So the only number I have is 4. I have a 4. Remember, you break it up into the numbers and each variable. So I have the 4. And then over here I have an x and an x squared. And then I have a y squared. Okay, so this is what our common denominator is going to look like. It's very important that you actually write it down, because if you can visualize it, you can compare and see what's missing. So, this is my common denominator. I'm going to come over here, and I'm going to multiply the top and bottom of the first fraction by what I'm missing, so that it looks like this. Okay? So what would I need to multiply times this to get that? 4, no, x. I already have I have 1x. So if you're trying to get x squared, you just multiply times another x. So my first fraction, I'm going to multiply times 4x. I'm not going to do it yet. I'm just going to identify what it is I need to multiply by. So multiply the first fraction by 4x. What would I need to multiply the second fraction by? X squared. Alright, now I'm going to actually do that. So in the numerator, this becomes 8x. In the denominator, I have my LCD. And then second one, I have 5y squared, and then my LCD. Everybody with me on that? Okay, now are the numerators like terms? No, so now all you guys have to do is actually link them together as an expression. So what would I have as my numerator? Operation with subtraction, so you have that minus there, all over that's your answer. Make sense? And then if they ask you to find restrictions, I don't know, did they ask that anywhere in here? They're not going to really ask. They could ask you for restrictions, but the restrictions work the exact same way as what we've been doing before. Once you get the fraction together, just look at the denominator and you write the restrictions like you normally do. But we're not going to focus on that too much. Okie dokie, here we go. These are the more complicated ones, so brace yourselves. Alright, so we're going to find the common denominator first, and that's going to start by factoring what? The denominator. So I'm going to come over here and directly underneath the denominator is where I'm going to do that factoring, okay? So if I'm going to factor this first one, what would it be? Okay, x plus 2, x plus 1. And then what would the denominator be of the second one? X plus 1, nothing really to do there. Okay, so then what should, excuse me, the denominator, or sorry, the common denominator be?
X plus 2.
X plus 2 needs to be represented. X plus 1 needs to be represented. Excuse me. Alright, so the first fraction, are we good? First fraction already has the common denominator. Second one? Second one is missing the x plus 2. So then our job next, once we decide what the common denominator is to multiply whatever fraction's missing something by whatever they're missing. So I'm going to multiply top and bottom by x plus 2. Okay? So in the first fraction, I'm just going to rewrite it because it's the same, so nothing changes. Okay. Now, in the numerator, I'm going to multiply x plus 2 times x plus 2, and because that is a binomial times a binomial, you will have to FOIL. Alright, so everything in the numerator needs to be worked out. Everything in the denominator can stay factors, but everything in the numerator needs to be worked out so you can actually combine like terms. So when you FOIL, and hopefully you guys have been FOILing for so long, you can kind of do it in your head. If not, you can go off to the side and do it somewhere. But when you FOIL, that's what you should get. Alright, again, the x plus 2 shows up in the denominator because I multiplied both top and bottom by the x plus 2. And then again, I go ahead and FOIL these two, and I get the x squared plus 4x plus 4. So then once you have the common denominators, I'm just going to go ahead and bring them together. They're going to merge to become one factor now. one fraction. So that means I'm going to add stuff in the top together. So if I have negative x squared plus x squared, they cancel, right? So all that's left in the top is the 4x plus 4. And then in the bottom I have x plus 1, x plus 2. Everybody see how we did that? That was the addition part. Okay? Now after you've added or subtracted and it becomes one fraction, it is one fraction by itself now, this is where you guys should try to simplify if you can. So after you've done all that process, you may not even still be done then. So after you've added them together, they become one fraction. From there, you would then do the simplify process like we started last class. So now, this is where you get to factor the numerator. You never actually factor the numerator until after you've done the whole process. So now if I were to keep going, this is kind of the after party, after solving kind of section here. So how would I factor the numerator? So then what happens? So the answer is really 4 over x plus 2.
Wait, didn't you say?
Yes. I'm expecting that after you do that entire process of actually adding the two together and you finish the actual process of adding the two fractions, I do expect, if you can, you won't always be able to, but if you can, to then simplify the result.
So in this case, you can like cross out.
In this case, because when I factored, there was a common factor top bottom, you cancel those and that leaves you with a more simplified form of the result. Okay? So if you can, you would definitely see if you can factor after you finish the question. Okay, so I know sometimes it does add more to the process, but that's just, it's part of the solving process. All right, let's try another one. Any questions about that one before we move on? All right, let's jump in. So how would I factor this first one over here? Okay, positive 5 minus 2. All right, and then the second one, no big deal, right? So then what is the common denominator? So I make sure I have one of each factor that I see. Okay. First fraction is good. I'm just going to rewrite it. First fraction was good, but the second one was missing the x minus 2. So I'm going to multiply top and bottom. Everybody agree with where I am right now? Okay. So what I'm going to do to actually pull these together as one fraction is to actually do this operation. Now, this is subtraction, right? So what I want you guys to see this as is this is really negative 2 being distributed to this set of parentheses. Can everybody see that?
Yeah.
I'm going to have to distribute the 2, but instead of distributing the 2 and then the minus because it's subtraction, I'm just going to see this as a negative 2 needing to be distributed. Okay? So what I'm going to do is I'm going to write 3 minus 4x like this, and then I'm going to distribute this through. So that becomes negative 2x plus 4. Did everybody see how I did that? I treated this minus 2 as one term that's being multiplied through so I could make it one expression along the top. Right, I just distributed a negative 2 through. That's how it became a positive 4. So this is where I'm at right now. Now can I simplify the top a little? I can combine some like terms, right? There's some terms in there I could simplify a little bit. So I have a 3 and a 4, so that's a 7, right? And then I have a negative 4 and a negative 2, negative 6. Can I factor that numerator at all? No. So if I can't factor the numerator, there's not going to be anything I can possibly cancel or simplify. So if you can't If you can't factor the numerator at all, you're done. You're done. So then that would be my answer. Okay? Questions about that? And you can write this in a different order if you wanted to rearrange it so it was negative 6x plus 7. You could do that if you wanted to. Alright. Let's turn it on. Start with red. Okay, so for the first fraction, what would go on with that one?
X minus 1.
Nothing happens, right? Alright, what about the second one? Yes. Oh no. Okay, so x minus 1, x minus 2. So what would my common denominator be? So convenient, you guys will see that conveniently, usually one of the fractions actually has the common denominator already set up. Not always, but oftentimes it will. Alright, so then what am I missing from the first fraction?
X minus 2.
So I'm going to multiply top and bottom by x minus 2. So again, you can do this in your head. I'm going to be multiplying these two together, so I'm going to go ahead and kind of distribute the x. So that becomes x squared minus 2x in the numerator there. And the second fraction does not need to be changed. And no, it doesn't matter in your common denominator what order the factors are in, as long as both of the factors are the same. The order does not matter. So it's okay that I wrote it that way.
Wait, so it's just x, you can distribute
You should. Yeah, if it's a monomial times any sort of polynomial, you distribute it.
So why didn't we do 3 minus 1, why didn't we just do 2x?
What?
So why did we do 2 and x minus 1?
Because, like I said, I wanted to do it as one step instead of two separate ones. I wanted to distribute as negative 2, not 2, and then distribute the minus. I mean, if you want to do it in 2 steps, you can, but I was kind of thinking ahead to do it in one instead of 2 steps. Okay, so now that the denominators are the same, I'm just going to go ahead and combine these two. So in the numerator, I'm going to have x squared, then I have minus 2x plus 2x. They go away, right? They cancel each other, so then it leaves me with the minus 1. And then I have x minus 1 and then x minus 2.
And you,
Now hold on. I've now finished the addition process, or subtraction, whatever. What do you check next?
check.
If you can factor the numerator. Can I factor the numerator? Yes, I can. So then the problem keeps going. Okay? Now just because you can factor the numerator does not guarantee you can actually simplify anything. So if you factor the numerator and then you don't see anything cancel, it's kind of a waste of time, but you still need to check. Because not every time will something cancel out. Okay? Make sense? Alright, so that's your kind of fundamental basic add subtract for your rational expressions. We're also going to talk about something called simplifying a complex fraction. A complex fraction is when you have a fraction within a fraction. So I have fraction, fraction, fraction. Fractions inside a fraction. So when you guys are doing a complex fraction, the main operation you guys need to pay attention to is that this is a division problem. So stuff that we talked about last class with division, the KCF, key change flip, we're still going to apply that here. The only thing that we're going to have to do first is that we're going to work with the numerator and denominator one at a time to get each of those parts of the fraction to be one fraction instead of two. So what you're going to do is you're going to combine these two, combine those two, and then do keep change flip, the actual division problem. Okay? So that's how you approach a complex fraction. It's still division, but within the division you have many add or subtract problems in the numerator and denominator to take care of. So what I'm going to do is I'm actually going to kind of extend the division out like this to keep them separate for now until I'm done with adding and subtracting the numerator and denominator. So looking at the numerator, what would the common denominator be between those two? 4. So then I multiply the first fraction by 2. That becomes 5 over 4. Simple enough, right? Alright, what about the denominator? What's the common denominator between 5 and 3? 15. So then I multiply the first fraction by 3. That gives me 18 over 15. And then second fraction I multiply times. So it gives me 10 over 15. 18 minus 10 is 8. So everybody see how I did that?
Yeah.
Okay, so now this, not the final answer, I'm just boxing it. This is what I'm going to focus on now. This is what I'm going to do keep, change, flip with. Once you've actually done the addition and subtraction or whatever operation in the numerator and denominator, your next job is to actually do the division problem, which is keep, change, flip. So, from there, I'm going to keep, change, flip. And then if you guys remember, after keep, change, flip, you see if you can cancel anything, and then if you can, you do, and then if you don't, or after you cancel, you multiply them together. Is there anything I can cancel? No? Okay, so if you can't cancel anything, you just multiply the tops, multiply the bottoms. So, 75? 32. If they ask you for restrictions for this one, you would say there were none because there are no variables. You only have restrictions if you have variables in the denominator. This one does not have any restrictions. Excuse me. Alright, let's keep on going. For this next one, again, I'm just going to look at the numerator and denominator separately for now. Alright, so when I see something like 4, it's 4 over 1. So you have to consider any constant or any like number that's not a fraction. You have to consider that to be over 1 so you can kind of find what the common denominator would be. So if I have 3 in one denominator and 1 in the other, what would the common denominator be?
3. Okay,
so the first one already had that. I would have to multiply the second one, top and bottom, by 3, so that would be 12 over 3. When I actually subtract those, what would the expression be?
X minus 12.
Right, because they're not like terms, so I have to leave it as an expression. Alright, this LCD, the least common denominator, be for the bottom set. It would be x. So they multiply first fraction by x. What would that be?
5x plus 1.
5x plus 1 over x. So then this is my keep, change, flip problem now. Keep, change, flip. Can I cancel anything? I cannot cancel the 12 with the 3.
And x? Oh, wait, no.
Can't cancel the x's either.
Wait, our last lesson, what we went to,
Oh, negative 12 over 3.
Not if 12 is part of a factor. If it's linked to something with your addition or subtraction, you cannot cancel it. Canceling is division, so the only time you can cancel something is if there's multiplication.
if it was another factor, so like x minus 12, you know,
If it was x minus 12 over x minus 12, yes. But you can't just pick and choose pieces of a factor to cancel with something. Because remember, cancel is division. You should really say divide instead of cancel, but canceling with fractions is division. So you have to be able to divide something. You can't divide this by 12. Or by 3, whatever. But yeah, so don't do that. You can't pick and choose. No. So there's nothing to cancel here. There's nothing to divide. So I'm just going to multiply them together. Oops. That's what the result would be. Alright. Questions about that one?
So with the monomials go on the outside.
Are we still on number 2?
Yeah.
Oh, yeah. I usually put those on the front. Alright, let's try this next one here. Our last one. What would the LCD be for the top set of fractions? 2x. So all I would have to multiply the first one by is 2. And that gives me a total of 5 over 2x. Everybody agree? Alright, well, would the common denominator be on the bottom here? Okay, so what would I multiply the first fraction by? And the second one? So it would be 7 over 12x. Right? So now that I've combined the numerator and combined the denominator, I'm now set to actually do the core.
Yeah, 3 times 3.
Oh, 9. Sorry. So that's 13. Okay, so sorry. Now that we have all that set up, we can do the core operation of this, which is divide, since the two fractions are being divided. So what idea do you use for division? Keep, change, flip. Keep, change, flip. I can cancel out the x's. Those go away.
Yeah, you cancel out 12.
And 2 and 12 leaves me a 6 here. So then I have a 5 and a 6 in the numerator, so when I multiply them, and then what's left in the denominator?